Welcome to Math Tutorials. In this video, we are solving every question of exercise 5.3 of Chapter 5, Continuity and Differentiability, from the NCERT Mathematics textbook for Class 12, Part 1. Exercise 5.3 asks for dy by dx in 15 problems, 8 implicit relations differentiated term by term, and 7 inverse trigonometric functions that collapse under the classic tangent, sine, and cosine substitutions. Here they are. Question 1. The relation ties x and y together linearly against sine x. We differentiate both sides with respect to x. Y is a function of x, so its derivative appears as dy by dx. Differentiate every term. 2x gives 2, 3y gives 3 dy by dx, sine x gives cosine x. Isolate the derivative. Question 2. Almost the same relation, but now the sine sits on y, so the chain rule fires on the right side. Every derivative of a y term carries a factor dy by dx. Differentiate both sides. The right side becomes cosine y times dy by dx. Collect the derivative terms on one side and factor. Question 3. Constants a and b, a y squared and cosine y, two chain rules on the y side. Differentiate term by term, tagging each y derivative. A x gives a, by squared gives 2by times the derivative. Cosine y gives minus sine y times the derivative. Move both derivative terms together and solve. Question 4. A product xy joins the party, so the product rule enters alongside the chain rule. Differentiate all four terms carefully. Product rule on xy, chain rule on y squared, tangent gives secant squared, y gives the bare derivative. Gather every derivative term on the left, the rest on the right. Divide to finish. Question 5. A symmetric quadratic relation set equal to the constant 100. The constant differentiates to 0, which keeps things tidy. Differentiate 2x, then the product rule on xy, then 2y times the derivative, all equal to 0. Group and solve for the derivative. Question 6. A full cubic in x and y with two mixed products, so two product rules are needed. Differentiate each of the four terms in turn. Term by term, 3x squared, then 2xy plus x squared times the derivative, then y squared plus 2xy times the derivative, then 3y squared times the derivative. Collect the derivative terms and the plane terms separately. Divide for the final answer. Question 7. Sine squared of y plus cosine of the product xy equals a constant kappa. Chain rule on the square, chain and product rules inside the cosine. Differentiate. The square gives 2 sine y cosine y times the derivative. The cosine gives minus sine of xy times y plus x times the derivative. Expand, then gather the derivative terms. 2 sine cosine is sine of 2y. Divide. Question 8. Sine squared of x plus cosine squared of y pinned to 1. Two chain rules, and the double angle identity finish it. Differentiate. 2 sine x cosine x minus 2 cosine y sine y times the derivative equals 0. Recognize both products as double angles and solve. Question 9. Inverse sine of 2x over 1 plus x squared. The shape of the sine double angle formula in tangents. The substitution x equals tangent theta collapses the whole expression. Put x equal to tangent theta. The fraction becomes exactly sine of 2 theta. So y is the inverse sine of sine 2 theta, which is 2 theta, and theta is inverse tangent of x. Differentiate the inverse tangent. Question 10. The fraction 3x minus x cubed over 1 minus 3x squared is the triple angle formula for tangent. The stated interval keeps 3 theta inside the principal branch. Put x equal to tangent theta. The fraction is exactly tangent of 3 theta. So y collapses to 3 theta, 3 times inverse tangent of x. Differentiate. Question 11. 1 minus x squared over 1 plus x squared, the cosine double angle in tangents. With x between 0 and 1, 2 theta stays in the principal range of inverse cosine. Put x equal to tangent theta. The fraction is cosine 2 theta. So y is 2 theta, twice the inverse tangent of x. Differentiate. Question 12. The same fraction as before, but inside inverse sign. Inverse sign of an expression is pi over 2 minus inverse cosine of the same expression. Use the complementary identity to convert to the inverse cosine we already solved. The constant differentiates away, leaving minus the previous derivative. Question 13. The sine double angle fraction, but wrapped in inverse cosine. Convert to inverse sine with the complementary identity, then reuse question 9. Inverse cosine is pi over 2 minus inverse sine, and question 9 gave that inverse sine as 2 inverse tangent x. Differentiate, the constant vanishes. Question 14. 2x root 1 minus x squared. The sine double angle written with sine and cosine. This time the substitution is x equals sine theta. Put x equal to sine theta. The root becomes cosine theta, and the product is sine 2 theta. So y is 2 theta, twice inverse sine of x. Differentiate the inverse sine. Question 15, the last one. Inverse secant of a reciprocal hiding the cosine double angle. Inverse secant of 1 over u is inverse cosine of u, and 2x squared minus 1 is the giveaway. Convert the inverse secant of a reciprocal into an inverse cosine. Put x equal to cosine theta. 2 cosine squared minus 1 is cosine 2 theta, so y is 2 theta. Differentiate the inverse cosine. That completes all 15 questions of exercise 5.3. In the next video, we will take up exercise 5.4 on exponential and logarithmic functions. Thank you for watching. If you found this video helpful, do like it, subscribe to math tutorials, and share it with your friends.